This is question number 21 from the 3.3 MyLab math homework on product rule and quotient rule. And the function we're given is set up to use the quotient rule. So when you're doing the quotient rule, make sure you stay super organized. I'm going to indicate the top function, and I'm going to write that letter T. So it's a linear binomial raised to the 5th power. And then I'm going to indicate my bottom function. The function on the bottom over here is just a linear binomial. Okay. And here I can see this little extra notation is telling me that my input variable is a t. So I can see my input variable is a t here. Remember, it's rise over run, change in outputs over change in inputs. So since the dt is in the denominator, that tells me that t is the input variable. And since t is the input variable, then that just means that if you have the derivative of t, it's just going to be a 1. So we're treating the letter t like a normal everyday variable, and that's going to make our chain rule a lot easier in some cases. So let's go ahead and find the derivative of the top and the bottom. So when I take the derivative of the top, I see that I have a base being raised to a constant exponent. So that means I need to do my power rule, and I'm going to apply the chain rule with that. So my power rule says you drop the exponent down to the front. So I'll drop my 5 down. I'll rewrite the base exactly as it's given to me. I'll decrease that exponent by 1, and then I'm going to tack on the derivative of the base. Okay. And again, my base is just what's inside the parentheses, the 5t minus 4, so I'm taking the derivative of the 5t minus 4. Okay, so let's go ahead and continue on with that. So my derivative is going to be 5, rewrite the base to the 4th power, and the derivative of 5t minus 4 is just 5. It's a linear binomial. The t is a normal everyday variable, so the chain rule isn't needed. The slope of that linear binomial is just 5. The derivative is just 5 there. And then I can go ahead and clean this up a little more because order doesn't matter when we multiply. So I'll just multiply the 5 times the 5 to get 25. So then I'll write that 25 factor first, and then I'll put the binomial to the 4th power at the end. Okay, now I'm going to go ahead and do the derivative of the bottom. This is way easier because this is in the form y equals mx plus b. But instead of an x, they're using a t. So I can see that understood 1 in front of the t. The t is a normal everyday variable. So the derivative of the bottom is just 1 here. Or however you can get the derivative of the bottom being a 1. And then we'll just apply our quotient rule. So let's go ahead and do that. So the way this notation is written, there's no pretty shortcut for it. There's no like a y prime or f prime of x or anything. So I'm just going to rewrite that. Okay. And that's equal to the bottom, which was a binomial, so I'm going to put it in parentheses, times the derivative of the top, so that's 25 binomial to the 4th, minus the top, so that was the binomial, to the 5th power, times the derivative of the bottom, which was a 1, all over the bottom, which was the t plus 5 squared. Okay, so that's your raw derivative. MyMathLab might accept that if you type it in, but we're going to do the algebra to clean this up. We're going to practice that a little bit. So how can we clean this up? So there's a lot of things we can do here. The easiest thing I can see just off the bat is that in the last group, when I multiply by a 1, that doesn't change the binomial value, so I don't really need to write that times 1 there. And then there's some algebra we can do here that might not be intuitive at first, but instead of trying to distribute 25 into this binomial, and then, well, we could, I don't know, would that be your gut? It might be your gut. Let's just go with that. I mean, let's go with your gut. Probably, no, just note, I can't distribute 25 into this binomial. That's not allowed, because the 5t minus 4 binomial is trapped by an x to the 4th power. So just a quick reminder, going back to PEMDAS, distribution is a type of multiplication, and you have to work exponents before you multiply. So I cannot distribute 25 into a binomial that has an exponent other than 1. But the t minus 5 has an understood exponent of 1, so I can distribute the 25 in there. I don't know. Let's see what that looks like when we distribute that. So that would give me 25t plus 125. And I'm keeping that in parentheses because it's a binomial. Then I'm going to rewrite my binomial to the 4th power minus my binomial to the 5th power. And all of that is over my binomial, my bottom squared. Okay, so now we're going to do that part that I said might seem a little, not intuitive to most people. It's factoring out a GCF. We're going to factor out a GCF from the numerator. But when I look at the GCF, when I look at what this first group of stuff has in common with the second group of stuff, it's a binomial factor that they have in common. There's 4 factors of the binomial 5t minus 4 in the first group, and there's 5 factors of it in the second group. So my GCF is going to be the 5t minus 4 to the 4th power. I can factor out 4 of them, and this is what it's going to look like. So I'm going to factor that out, 5t minus 4 to the 4th. And let's see what's left over from each of those groups when I factor that out. So I'm going to have the first group minus whatever's left over in that second group, right? So let's see what happens. So in this first group, if I factor out all 4 of the 5t minus 4 binomials, I'm going to be left with just a 25t plus 125. And then in that second group, I factored out 5 of the binomial factors, so one of them is going to be left. So I'm going to be left with a 5t minus 4, and it's a binomial, so I'm going to still include that in parentheses, even though the understood exponent would be 1. We don't write that. And I need to do that because my quotient rule has subtraction built in. So when I simplify this, I'm going to end up needing to distribute that subtraction to both terms of that second binomial. And again, all of that is over, I'm writing out of space. All of that is over my bottom squared. Okay, so let's clean that up a little bit and see what that would be. So I would have my binomial GCF that I factored out. Okay, and all that's over the bottom squared. And there's nothing I can do to simplify those binomials because they're not identical. And then in the brackets, what are we left with? So we have, let's see, we have 25t minus 125 minus a 5t plus a 4 when I distribute that subtraction. And then we'll just go combine like terms to clean that up. If I have 25 t's and I subtract 5 of them, that's going to give me 20t overall. So I'm going to subtract those 5 there. And that's going to give me 20t. So let's go ahead and do that. I'm running out of space, so I'm trying to write this as compact as possible. So it ended up being a 20t. And then if I have negative 125, but I add 4 back, so negative 125 plus 4 would be subtracting 121. So I'll go ahead and write that in there. Sorry, there's a delay on my app and it's messing with my pin choices. Okay, and then I can change those brackets to parentheses if I want. Okay, and nothing in there is going to, there's no like terms, there's none of these binomials are going to divide out because they're not identical. I may or may not be able to factor something out of the second binomial. I don't think I can because 121, yeah, that would just be 11. And 11 doesn't go into 120. But even if I could, it probably wouldn't look like t plus 5, so it wouldn't divide out anyway. So that's it. That is my derivative. So just note, the calculus stopped way up here at the raw derivative. That's where the calculus stopped. Everything I did after that was just algebra. Distribution is algebra. Factoring out a GCF is algebra. Combining like terms, distributing a subtraction, combining like terms, all that was just algebra. Okay, so As always, if you have follow-up questions, just shoot me an email.